In section 2.1, we look at first-degree equations with one unknown. So solutions of equations in one variable consist of one number that forms a true statement when plugged into the equation. So for example, number 1 is 1/3 a solution of the equation 2a plus 5 equals a plus 6. So we want to plug it in and see if we get a true statement. So 2 times 1/3 plus 5 equals 1/3 plus 6. Now let's start with the left-hand side. Remember that we can always write numbers with a denominator of 1 if it's not written there already. And so we can then simplify the left-hand side. We've got 2 times 1 on the top, which is just 2, and then 1 times 3, or just 3 on the bottom, plus 5. And then I'm just going to rewrite the right-hand side. Now we have fractions that need to have common denominators so we can add them together. So I'm going to write my denominators of 1 so I can figure out the common denominator. And so looking at the left-hand side first, between 1 and 3, I can multiply the 1 by 3 on the top and bottom so that I can get a common denominator. And then on the right-hand side, I'm going to do the same thing with the 6/1. Multiply by 3 on the top and bottom. So on the left-hand side, we have 2/3 plus 5 times 3, which is 15 over 3. And then I have 1/3 plus 6 times 3, which is 18 over 3. So now we can add the numerators. On the left-hand side, we've got 2 plus 15, which is going to give me 17 over 3. And the right-hand side, I've got 1 plus 18, which is 19 all over 3. Now 17 over 3 does not equal 19 over 3, so this is not a true statement. And because we did not get a true statement, we got a false statement. That means that this is not a solution. And so the procedure for solving first-degree equations with one unknown, first we want to remove grouping symbols in the proper order. If fractions exist, we're going to multiply both sides of the equation by the least common denominator of all the fractions. We're going to combine like terms if possible. We'll add or subtract a variable term on both sides of the equation to collect all variable terms on one side of the equation. And then we'll add or subtract a numerical value on both sides of the equation to collect all numerical values on the other side. We'll divide both sides of the equation by the coefficient of the variable. We'll simplify and then check your solution. So solve and check. We have 1/3 y equals -6. So we need to get rid of the fraction. And so we're going to multiply both sides by the LCD, which in this case is going to be 3. What I do to one side, I have to do to the other. Well, on the left-hand side, the 3's are going to cancel, and we're just left with y, and -6 times 3 is -18. You want to check your solution. We plug it back in to the original. So we have 1/3 times negative 18 equals negative 6. Well, we can simplify. We can take a 3 out of 3 into 3 out of negative 18, which leaves me negative 6. And we are ending up with 1 times negative 6, which is negative 6. And that's definitely equal to negative 6. So that means that the answer we found is definitely a solution. Let's do the same thing for example number 3. Something a little bit more complicated. So we need to get rid of these grouping symbols first. So we are going to distribute the 3, and we're also going to distribute the negative 2. So we have 3 times 3x, and we've got 3 times 2, minus that 4x equals, we've got negative 2 times x, and negative 2 times negative 3. So let's go ahead and simplify. We have 9x plus 6 minus 4x equals negative 2x plus 6. So let's go ahead and combine like terms on the left-hand side. We have a 9x and a negative 4x. That gives me 5x plus 6 equals negative 2x plus 6. So what we want to do is we want to move all the variables to one side and all of those numbers or constants to the other. And so I am going to add 2x to both sides. And so on the right hand side it ends up canceling. And on the left, we end up with 7x plus 6 equals 6. And we need to move that 6 on the left over to the right, so the variable is by itself. So we're going to subtract 6 from both sides. Well, what ends up happening is that the 6's cancel on both sides. And so we end up with 7x equals 0. And then we can divide by the coefficient to get x by itself. So we're going to divide by 7 on both sides. And we end up with x equals 0 divided by 7 is just 0. You can always check this solution. So plugging it back into the original, we have 3 times 0 plus 2 minus 4 times 0 equals negative 2 times 0 minus 3. Well, inside the parentheses, 3 times 0 is going to go away. Negative 4 times 0 is going to go away. And so we've got 3 times 2 equals negative 2, and 0 minus 3 is just negative 3. So on the left we have 6, and negative 2 times negative 3 is also positive 6. So that solution checks out. Let's try example number 4. So we have x over 5 plus 1/2 equals 4/5 plus x over 2. We need to get rid of all these fractions. So we need to find the LCD. We're working with a 5 and a 2. So what do these both go into? My LCD is going to be 10. So we want to multiply every single piece by 10. And so what this ends up doing is we can simplify each fraction to get rid of that denominator. So 5 goes into itself once, and it goes into 10 twice. 2 goes into itself once, and into 10 5 times. 5 goes into itself once, and into 10 twice. And 2 goes into itself and 10 5 times. So now all of my denominators have become 1, and we just have numerators. So the first term, we've got 2 times x, which is just 2x, plus 5 times 1, which is 5, equals 2 times 4, which is 8, plus 5 times x, or 5x. And so now this looks like a problem we just solved. So we want to move all the x's to one side. So I'm going to subtract 2x from both sides. And so on the left it cancels, and we're left with 5 equals 8 plus 3x. We want to get all the constants to one side, so I'm going to subtract 8 from both sides so that I can get x by itself. On the right hand side it's going to cancel, and we have 5 minus 8, which is negative 3, equals 3x. And then we want to get x by itself, so we're going to divide both sides by 3. And so it cancels on the right, and negative 3 divided by 3 is negative 1, and that's equal to x. So we can go ahead and check this. Let's check it in the original. We have negative 1/5 plus 1/2 equals 4/5 plus negative 1/2. So we need to have a common denominator. So we're going to make this first term have a 10 by multiplying by 2. The second term we're going to multiply by 5. And then on the opposite side we're going to do 5 times 2, and then a 2 on the top, and 2 times 5 with a 5 on the top. So we end up getting negative 2 over 10 plus 5 over 10 equals 8 over 10 minus 5 over 10. And so because we have common denominators, we can just simplify the numerators. Negative 2 plus 5 is going to give me 3 over 10. And 8 minus 5 gives me 3 over 10. And that's definitely a true statement. And so we know that x equals negative 1 is a solution. Now we're going to look at example number 5. We're working with decimals. Don't let that scare you. So the first thing we want to do is get rid of those grouping symbols. We're going to distribute 0.2 to both pieces, and then negative 3 to both pieces as well. So we've got 0.9 plus 0.2 times x, and then 0.2 times 4 equals, we've got negative 3 times 0.1x, and then negative 3 times 0.4. So let's simplify. We've got 0.9 plus 0.2x, and 0.2 times 4 is going to give me 0.8. On the right hand side, we've got negative 3 times 0.1x, and so that gives me negative 0.3x. And then negative 3 times 0.4 gives me negative 1.2. And so we actually end up having a double negative on the right hand side. And so let's go ahead and combine like terms on the left hand side. We've got 0.9 and 0.8, which gives me 1.7 plus 0.2x equals negative 0.3x plus 1.2. So let's go ahead and get our x's on one side. We're going to add 0.3x to both sides. And so it cancels on the right hand side, and we get 1.7 plus 0.5x equals 1.2. And then we need to get the constants on one side. We got minus 1.7 on both sides. And so on the left, it cancels, and on the right I am left with negative 0.5. And so our last step is to get x by itself by dividing by 0.5. And we end up getting x equals negative 1. And so you can check it on your own, see if you get a true statement, which you will. And the last one. Same thing, we want to make sure we distribute first. So we're going to distribute 5, and we're going to distribute negative 2. So we have 5 times x, and then 5 times 2, plus 3x equals 10x. And then we've got minus 2 times x, and minus 2 times 5. And so simplifying, we get 5x minus 10 plus 3x equals 10x minus 2x minus 10. We can combine like terms on the left-hand side. We've got 5x and 3x. And on the right-hand side, we have a 10x and a negative 2x. So we end up getting 8x minus 10 equals 8x minus 10. Well, that's interesting. I've got the same thing on both sides. And so if it's the exact same thing, it doesn't matter what I plug in because it's always going to be equal. But let's go ahead and keep finishing up here. Let's just say we need to get x's on one side. So I'm going to subtract 8x from both sides. Now what ends up happening is that it ends up canceling on both sides. And we get that negative 10 equals negative 10. And that is always a true statement. So because our variable canceled and we were left with a true statement, that means that all real numbers is your solution. It doesn't matter what you plug in, you will always get a true statement. Had you gotten rid of the variables but gotten a false statement, like 0 equals negative 10, then the answer would have been no solution.